Good evening, guys. It's good to have you back. Yesterday, of course, we talked about account abstraction, building account abstraction from scratch. And then at the end of, before the end of our lecture yesterday, of course, we ran into a few bugs. Let me just share my screen. Uh, okay, awesome. I hope you guys can see my screen. So, all right. So yesterday, guys, we ran into some bugs when we're trying to get our user operations. And just a recap, of course, we have our smart account that validates the user transaction here. And then, of course, we want to run this execute command so that we can always confirm that, of course, the count, which is we're trying to change the state of the blockchain. So actually the count is actually what is going to help us know that truly we are changing the state of the blockchain. So as of yesterday, we did deploy our account factory. This is the address of our account factory. And then, of course, we did also deploy our entry point, and this is the address of our entry point. So what we were trying to do as of yesterday was to try to send a user operation. And of course, going back to, let's just look at this, going back to ERC 437, the documentation. Yeah, of course, this is a user operation. And of course, we had to fill in all these parameters. So yeah, we arrived at this. Of course, we had the sender, which is our smart wallet. And then we had our init code, we had our sender, the smart wallet, we had the nouns, we had the init code, the core data, gas limit, and all of these parameters. Now, the important thing here is this function handle ops, right? So what handle ops actually is doing is taking this user operation and then sending it to our entry point. And of course, the entry point will validate this transaction and our smart contract will execute this operation. So yeah, so from where we stopped yesterday, we're trying to run our execute script. So if we run npx hadat run scripts, we're trying to run our execute script as yeah. So we try to run our execute script and then yeah, invalid bigish big numberish value. Okay, so we're getting this error because let's look at our execute again. Invalid big numberish. All right. So this is actually coming from we have our init code, we have our factory nouns, we have okay. First, we have an error here. This is nouns, not yeah, when creating our smart account, you're having the nouns. That was a typo on my part. Sorry about that, guys. So yeah, we'll fix that nouns and then yeah. So let's try to run this again. Let's save this and try to run this again. So let's try to run this script again, execute. And let's just wait for it to run. Okay, so now we've solved that, but we're having another error, invalid byte-like size, and this is the value. Okay, so we are getting this error because the our init code is supposed to be 20 bytes. So we're having this error because our init code actually you have to take out the 0x at the beginning so that we just have the 20 bytes of init code, right? So going back to our init code, let's do this. Let's slice it. Let's take out the first 2 bytes so that we have 20 bytes. And then after doing that, we also need, okay, we have our init code here. Yeah, so let's just, since I restarted our hard local node, so we'll try to send, we're going to try to send Let's try to also send money back into our entry point. And then let's see what happens. We have our init code. We have sending money to our entry point so that we can execute our function. Remember, we encoded this function. This is what we're trying to execute. This call smart account function. So what we are doing is we're trying to call this function executes, this executes function. So what we did is we encoded it with, of course, the interface method of encode function data. So let's see. Yeah. Okay. So I hope everything is working out well. So let's try to, of course, send this execute this again. npx header run script executes. So just wait for that to confirm on the blockchain. Yeah, awesome. Yeah, guys. So finally, using account abstraction, we've been able to send our execute using this handle ops, which is a method. This handle ops is actually gotten from, you go back to our node models, we check account abstraction, we check our, I think it's nonce manager, yeah? So let's look at nonce manager, I think nonce manager. So handle ops is actually entry point, right? So it has a tons of functions we can actually use. So this executes, yeah. So this is what we did. We call this function handle ops. And what we are telling this function was passing in our user operation as an argument. And then the beneficiary of this user operation, of course, is our smart account, meaning, our externally owned account. So this means that we are sending transaction from our externally owned account, and our entry point is actually going to pay for our smart account is actually going to execute that contract, and using account abstraction, we're going to have it pay for the gas for that transaction, which of course we see this a transaction hash here. And then this transaction was gotten from this address, which send address, which is the owner, of course, and it was sent to our entry point. Remember, this is the address for our entry point. So this address from is gotten to, if we look at our node, our local hard node that we ran, of course, this is the transaction we send. You can see that the entry point called the handle ops function, and this is the transaction hash. And the sender of this transaction actually is our externally owned account, which we got, of course, from Hada. Now, if we looking at this account, we have 2266. So this should be like the first account on our, this should be like the first account. Yeah, this, yeah. So this is all, these are all, yeah, I'm sorry about that, guys. I just, for the major little distraction, sorted it out. So yeah, so I was saying that this is our sender, the first account from our local hard and node accounts that were given, of course. So yeah, we're able to execute that. We're able to use account abstraction to actually call a function from our smart account, but it is the smart account that handled, and the entry point handled the validation, and then the smart account executed it, and the gas was paid on behalf of the externally owned account. So just to confirm, I'll say let's run some tests, right? So that we just confirm this. Let's know if of course, remember we've sent a transaction, right? So initially our count here is 0, right? So now that we've sent a transaction, we expect this count to be 1, right? So, but before we do that, let's try to send another transaction, and then so that we'll be sure. So that this time we know that what we are expecting is we're expecting to have 2 counts, right? So our count is supposed to be 2. But to do that, remember our init code here. This init code, if you go back to the documentation, right? So if you go back to the documentation, you'll see that the init code is used to deploy an account, if not yet on chain. But now that we've deployed our smart account, we don't need to call this init code in our user operations, right? So let's just remove this init code. We'll just replace it with our string. Let's call it OX, so that we can be able to send other transaction. But let's just look at what happens if I try to send another transaction with the init code after creating the smart account. So I'm actually expecting an error, right? So let's run our execute function again. Yeah, I've done that. So let's see what happens. Yeah, so as expected, we have a failure because why? The error here is that the exception while processing transaction. We have a fail of a sender already constructed, right? So we have already constructed our init code. So that's why I say we can just replace this. And then let's try to send another transaction. Yeah, so we've sent 2 transactions, right? So let's write a test, right? Let's just have a simple test to know, to be sure that actually what we are doing, we are actually changing the state of the blockchain. Remember, we've sent this transaction twice. So we are expecting our count number to 2, right? So let's go to our script. Let's create a new file. Let's call this test, because we want to actually test to be sure that our smart account is actually changing the state of the blockchain, right? So the first thing we need actually, let's just get our smart account address, and then call the state variable count to see how many times the blockchain state has been changed, right? So we'll get, of course, as usual, we'll get an instance of Ethers from Hadat. So we're going to require Hadat. Let's require Hadat. And then what do we do? We then, let's call this function, let's just call it main, takes no argument, right? So our main function, what we want to do, we want to get our smart account, right? So let's say our smart account contract. So let's get our smart account contract, and then we're going to use Ethers. I think we should use get created at, right? So we get created at, not created at. Then remember, we are going to pass in the name of our smart account, which is smart account. Yeah, this is this name, smart account. So we are getting the name of our smart account and then the address of our smart account, right? So yeah. So let's get that. This is the address for our account factory, address for our entry point. I think our smart account, this is our smart account address, yeah? So we'll just get this. Yeah, awesome. So we're passing it in our, we're trying to get an instance of our smart accounts contract, right? So this is smart accounts. Okay, so let's get the address. First, let's call this our smart accounts. Then we'll pass in the address. Awesome. Then we can then call our smart account contract at that address, right? So yeah, awesome. So we've gotten that, and then the only thing we need to do actually is just to check our state variables, right? So let's say constant, let's say our count from our state variable. Because we want to know the number of times, we've done that twice, right? So we want to know the number of times the state variable has been changed just to confirm that actually our smart account is changing the state of the blockchain. So let's get that state variable. Let's call this, this should be not base account, this should be account. No, this should be smart accounts, our smart accounts. Here we have smart account contract. Yep. Then we are going to get dot count, right? So let's get that. Um, so, yeah, so we are going to get the count, and then let's just also check our owner, right? So let's check the owner of this smart account. Let's say owner. Then we just call the state variable for the owner, right? So our smart account contract dot owner. So yeah, so that's just it. We just need to check and confirm this. To then we are going to console.log what we have. Let's say we are going to console.log. Let's do it this way. Let's say smart accounts is then passing our accounts, and then we also in a new line, let's get our smart account owner, right? So our smart account owner is also going to be the owner. Yeah. So let's run our test, and then yeah, we need to call our main function. We haven't done that. So let's call our main function, and if catch any error, as always, we will catch any error. What do we want to do? We want to see that error. So console.log that error, and then we then reverse the process, right? So we are going to exit. So process.exit code. And then our exit code is going to be 1 because we want to return it. We want it to return, right? So yeah. All right. So having gotten that, yeah, let's try to run our test script. So that would be npx hadat run script, but this time we're running tests. And let's see the number of counts we're having, right? Okay, smart account of count is not a function. Okay, awesome. So it's not a function, but it's actually a state variable, and we're supposed to actually be able to get that. So let's look at it. So what do we have here? We have execute, we have count, we have counts. Yeah, I think it should be an error with my typo. Yeah. So let's look at this together, guys. So it is the fun of it, right? We are getting the smart account, and then we are getting our address, right? So let's just console log. Let's try to see what's happening there. Let's console.log our smart account contract, just to be sure that we are getting the smart account contract, right? So let's test. Okay, so we have a promise, so we have to await this. Let's await this. All right, I just want us to be sure we are getting the right smart account. So yeah, so we have our smart account, but then this is the address of our smart accounts, right? So let's see. This is the address, and then this is the address of the owner, right? So let's see. What are we missing here, guys? What are we missing? So if the contract goes, we should be able to get the count, right? So count is not a function, but it's a state variable. So let's see. Let's try it one more time. So guys, this happens in coding, you have to debug and debug. Sometimes things don't go. So smart account dot owner. Yeah, so absolutely, yeah. Of course, now we see the address of our smart account. This is the address of our owner, and then this is the address of our smart account, right? So we try to run our execute function again. Let's try to run the execute function one last time. Yeah, so we have another function, right? So awesome. Uh, let's see. Let's try. I think we have a naming convention issue. So this will be smart account of the accounts, not missing counts, but counts. Yeah. All right. So guys, yeah. So this is it. We've been able to, of course, execute using account abstraction. We've been able to actually use our externally owned account to send user operations to our entry point. And then, of course, our entry point validates this transaction and have our smart account execute this transaction on behalf of our externally owned account. So yeah, guys, it's been awesome. And of course, remember we have third part of the series where we're actually going to try to do stuff on chain. We're going to try to actually deploy our smart account on Arbitrum. So of course, do well to, of course, we've sent out email, but do well to also go to our Twitter page, which is at It's Lagos. Of course, follow us on Twitter. The link to the next lecture series is actually on the Twitter's page. So do well to follow us on Twitter, go to that link, open that link, and join us for the third part of our account abstraction series. See you guys there. It's been awesome with you guys. So see you there.